difficulty, okay? So my suggestion when you do a word problem, number one is read through the question twice. So I read it twice. Rowing at 8 kilometers an hour in still water. Alana and Carissa take 16 hours, throw 39 kilometers down a river and 39 kilometers back up. Find the speed of the current to 2 decimal places. The last sentence in a word problem will tell you what you're looking for. Okay? So, with that said, what are we actually looking for in this question? The speed of the current. Very good. So I'm going to instantly write let x equals speed of the current. Okay, let's look at this question and see what else we know. Can somebody give me just some given information based on the question? Because there's tons and tons of stuff in this question. Tell me some piece of information that you know. Yes? Very good. Okay, so I'm going to use that. Their speed with no river would be 8. Okay, so it looks like to me in this question they're not going just in still water. They're either going with the river or against the river. So when they're going with the river, what's their speed going to be? Going with the river. Go ahead. 8x. No, close enough. Use an 8x as a, sorry? 8 plus x, okay? So we're going to say then therefore 8 plus x equals speed with the current. Okay, so they'll be going a little bit faster. Okay, so to go the other way, so that's going with the current. What's their speed against the current going to be then? 8 minus. Very good, 8 minus x. Okay, what else do we know? There's lots of more information than we know. Robin, go ahead. Time, what do we know? So we know that 16 is going to be your total time. That's a long day of pathing, by the way. That's a lot of pathing in one day, 16 hours of pathing. That's a lot. What else do I know here, though? There's still 2 more things that I know. Oh, and go.
You have 2 separate distances and total distance.
Yeah, so I'll do this separate. So I'm going to say 39 is going to be your distance upstream. And 39 is also going to be your distance downstream. Now here's the thing that gets people confused, and I want to just be clear about this. Why can't I just say their total distance is 78? The total distance is 78. Let me say that's wrong. That is right. But why can I not use 78 as a number in this equation? Yeah, Luke?
Because it's not going to really help you look for the individual speeds.
Yeah, you're going to need individual speeds, right? Because their speeds are different going up and down. Like think of if anyone here has gone running before, which hope you all have. If you're running uphill and you're running downhill, they're way totally different things, right? If you say, man, I ran 10 kilometers today, okay, but 8 of it was uphill. That's a lot different than running, 10 kilometers straight, right, or 10 kilometers downhill. It makes a big difference. So in this case, the same thing too. 39 and 39 have to stay separate in this equation. Now let's get a few things in here. I'm going to go back to physics class or grade 9 or 10 science. This to me looks like a velocity question for sure. What's the equation for velocity, please, or for speed? Nobody knows it, that's fine. You guys all know it is with a triangle, okay? People use this one here, but I'm going to do it interesting with a triangle because I don't really get the triangle. The triangle's like this sort of thing, right? Is that it? I don't like that triangle. I'm going to use Brad as an example. Brad, when your dad drives down the road, how fast does he travel? Okay, let's say he travels 80. 80 what though, Brad?
80 kilometers an hour.
80 kilometers per hour, okay? So the way that goes is kilometers per hour. So V equals D over T. Speed is kilometers per hour. Now the problem is here, we're going to make a new equation here. So I know my total time. What we're going to use for this, we're going to say that the total time equals the time upstream plus the time downstream. So 16 is my total time. Can somebody give me, going back to this, if I say that V equals D over T, what's the expression for time? What does time equal? This is over velocity, yeah. So T is going to be then D over V. Okay, so could somebody be brave? Tremendously brave. And give me an expression for their time upstream. What is their time upstream going to be? Okay, let's try again. What's their distance upstream going to be? 39, good. What is their speed upstream going to be? Plus X. So that's all I did is I'm using this right here and I'm just subbing it over there. 39 over 8 plus X, great. What is their time down? Whoops, I got that backward. E minus X, that's okay. What is their time, what is their distance downstream? Yeah.
39 over 8 plus X.
Very good. I'm going to use a domain this time instead of restrictions. What are the possible speeds that the twins can be paddling? What does their speed have to, or what's the speed of the river have to be from what to what? What are the possible speeds for the river to be? 0 is the minimum, the smallest. What's the biggest speed the river can go? Some would say infinity, I'm going to say non-infinity. Okay? Sorry? Nope, not 39. Well, think if the twins are paddling 8, imagine if the river's going 9 kilometers an hour. What does that mean? We're going backwards, so we don't like that. So we're going to say, as far as my domain, we're only going to use x's from 0 to 8. Just less than 8, okay? Because it's impossible. Right, if you have a river that's going 22 kilometers an hour, please don't get in a canoe, okay, if the river's going that quick, okay? Right, and again, we're going to only use positive directions here. Are you okay with the logic of this? Okay, I'm going to hit pause, and we're going to do lots of these examples today. At this moment, you guys are solving for x, that's what you're doing, okay? So at this moment, now you're looking at me, Rob, and saying, I don't know how. You do. That was 5 questions you did for homework last night. You're solving for x. So what you're going to do now is you're going to multiply by this to get rid of the fractions, okay, right? And then solve for x, that's what you're going to do, okay? Have confidence in yourselves, Tristan. You can do this. Stand on, okay. Solve for x, you can do it. We'll deal with the word problems in a sec. We'll do lots of these. Oh, wait a second, I have pause here. So these